Hai, Assalamualaikum and good day everyone. So for this video, kita akan tengok part 2 untuk physical properties and it involve acidity of the carboxylic acid. So, as the name itself, carboxylic acid. So carboxylic acid is an acid and it is the most acidic class of compound compared to other organic compound. Okay, but it is still a weak acid lah if you compare with H2SO4 sulfuric acid ataupun HCl hydrogen chloride. Okay, tapi kalau contoh kita compare carboxylic acid dengan ada compound contoh alcohol, so carboxylic acid is the most acidic. And this is because of the resonance effect and also inductive effect. So kita akan tengok apa itu dua benda ni. Okay, so acidity of carboxylic acid, basically kita akan tengok comparison. Okay, so kita akan ada resonance effect dengan inductive effect. So inductive effect pula terbahagi kepada dua. Satu, electron withdrawing group EWG, and the next one is EDG, electron donating group. Okay, so untuk resonance effect biasanya akan compare between carboxylic acid, phenol and alcohol. So inductive effect, so what happen if you have electron withdrawing group and what happen if you have electron donating group. Okay. Okay, now kita tengok resonance effect. So basically kita dah pernah jumpa dah resonance effect before this in previous chapter. So in this chapter, resonance effect tu dalam carboxylate ion. Okay. So bila carboxylic acid, okay, kamu akan buat cleavage dekat sini and you will form carboxylate ion. Okay, so this carboxylate ion yang kita akan tengok the resonance effect, what happened here. Okay, so the negative charge on the carboxylate ion akan delocalize between the two oxygen atom. So, 1, 2. Okay, so these two oxygen atom, okay, this will cause this carboxylate ion will become more stable. Okay, so untuk resonance effect, kita akan tengok the stability of carboxylate ion. So, as I mentioned before, it is the resonance effect. This negative charge is being delocalized equally between two oxygen atoms. So, remember, oxygen is highly electronegative atom. Okay, so sebab tu dia menjadikan this carboxylate ion lebih stable compared to phenoxide ion. Okay, so nanti kita akan tengoklah phenoxide ion. Ini kita dah jumpa before this dalam chapter hydroxy compound phenol. The carboxylate ion more stable and dia akan prefer untuk release the H plus ion. So, bila concentration of H plus ion tinggi, that will make it more acidic. So next kita akan tengok inductive effect. So inductive effect ni depends on the substituent. Okay, so C double bond O OH. So dekat bahagian sini substituent dia adalah sama ada electron withdrawing group ataupun electron donating group. Okay. Oh, kalau ada EWG, dia akan tarik electron density. And kalau electron donating group, dia akan donate electron density. Okay. So, let's say sini ada bond hydrogen. Okay. So, kalau electron withdrawing group, okay, you tarik. Okay, so remember withdraw, tarik. So, tarik electron ke arah this way. Okay, so imagine the electron density here. Okay, so bila kamu tarik all the electron pergi ke arah electron withdrawing group, so what happen between OH bond ni, dia akan jadi weak, lemah. Okay, maksudnya dia akan easily be broken. So bila it is easily be broken, so you can form this carboxylic ion, this part carboxylic ion, and then kamu akan form H plus ion. Okay, so bila dia prefer untuk form this carboxylic ion, that means concentration of H plus pun bertambah. Okay, dia prefer untuk form. Okay, so carboxylic acid with electron withdrawing group is more acidic. Okay, but let's say if you have electron donating group. So kalau donating maksudnya dia derma atau beri elektron. Dia akan donate all the electron density towards this OH bond. So bila banyak electron density around here, that means bond between O dan H ni pun susah nak break. Okay, so that means kalaulah kamu nak form this carboxylic ion dengan this H plus ion pun, it is not favorable. Okay, sebab because of this electron donating group, it will destabilize, dia membuatkan this carboxylic ion less stable to form, and bila it is not favorable to form this carboxylic ion, that means H plus ion pun tak banyaklah dihasilkan. It's just very low amount of H plus ion. That is why dia akan decrease the acidity of with this carboxylic acid yang ada EDG attached to it. Okay, so now boleh beza EWG dengan EDG. Okay, now let's have a look at the effect of electron withdrawing group on the carboxylate ion. Okay, so bila kita ada electron withdrawing group, remember dia akan tarik the electron density. So electron withdrawing group attached to the carboxylate ion will delocalize the negative charge on the on the oxygen atom. Okay, so the electron density of the OH bond, so dekat sini kita ada OH bond, dia akan decrease. Why? Electron density yang bertumpu dekat sini, dia akan berkurang because of this electron withdrawing group. So dia akan tarik all the electron density towards itself. Okay, so it will make the OH bond will be, this bond will be weaker. So bila lemah bond dekat sini, it will be easier to break. So bila easier to break, so you akan form, okay, so this is carboxylic ion with H plus ion. Okay, so ini adalah conjugate base lah actually. Okay, so bila you can form this stable carboxylate ion ataupun stable conjugate base, okay, and it will form H plus ion yang banyak jugalah because it preferred to form this carboxylate ion. So bila concentration of H plus ion tu tinggi, that means the acidity increases, and kalau kamu ada the number of electron withdrawing group increase, lebih banyak, the acidity will also increase. Okay, sebab dia akan lebih menarik the electron density towards electron withdrawing group and make the OH bond just now becomes weak and easily to be break and form carboxylate ion and H plus ion. Okay, and strength of electron withdrawing group pun mempengaruhi. And for example, if you have a more electronegative atom, contoh fluorine, so dia akan lagi menghasilkan acidic compound. Okay, so kalau kita compare ada electron withdrawing group dengan tak ada electron withdrawing group. Okay, so let's say this one, 2-chloroethanoic acid, kita ada chloro dekat sini, and chloro is an electron withdrawing group, and ethanoic acid tak ada EWG. Okay, So the presence of chlorine atom on this compound, it is an electron withdrawing group. So it will reduce the electron density dekat OH bonds ini. Okay, so dia akan tarik electron density towards Cl. So make this OH bond become weaker and easily to be broken. And kamu boleh form carboxylic ion and H plus ion. Okay, so you will form a stable carboxylate ion compared to ethanoic acid yang tak ada electron withdrawing group. Okay, so bila OH bond will become easier to be broken, kamu akan release more H plus ion. It will make 2-chloroethanoic acid more acidic compared to ethanoic acid. Right, so next kita tengok effect of the number of electron withdrawing group pula. Okay, so the first one, kita ada 1, 2 chloro. And the second example, kita ada 1 sahaja chloro. So, 2 versus 1 electron withdrawing group. Okay, so 2,2-dichloropropanoic acid has 2 chlorine atom. And this one, 2-chloropropanoic acid ada 1 sahaja chlorine atom. Okay, so both akan tarik the electron density Cl, but kalau dekat 2,2-dichloro, dia akan lebih kuat menarik the electron density compared to kalau ada 1 sahaja EWG. Okay, that means in here it is more easier to break this OH bond, and therefore 2,2-dichloropropanoic acid is more acidic lah, because you can form a more stable carboxylate ion, and H plus ion pun tinggi. Okay, that means it is more acidic compared to the one with only 1 EWG. Kita akan tengok the effect of position of electron withdrawing group. Okay, so position of electron withdrawing group pun akan mainkan peranan. So the inductive effect are dependent on the distance. Okay, kalau electron withdrawing group tu dekat dengan C double bond OOH. Okay, so kalau electron withdrawing group tu dekat dengan COH, okay, dia akan lagi kuat menarik electron density toward Cl atom. Okay, kalau Cl ataupun electron withdrawing group kamu tu away jauh daripada C double bond OOH, okay, dia punya tarikan tu kurang sikit, less. Okay, sebab dia kena melalui karbon 1, karbon 2, karbon 3 dulu, barulah ke Cl. Right, so the explanation is Cl atom is nearer to carboxyl group in 2-chlorobutanoic acid. Okay, this one. Compared to 4-chlorobutanoic acid. Okay, so ini jauh. Right, so the OH bond is weaker. Therefore, okay, H plus ion will be easily released. That is why 2-chlorobutanoic acid is more acidic because of the distance between electron withdrawing group to the carboxyl group. Right, so next kita tengok effect of electron donating group. Donating means beri electron. Okay, so if you have electron donating group, it will donate the electron density towards this COOH. So let's say kamu ada COOH. So kalau dia bagi ataupun dia beri all the electron ke arah OH bond, that means, okay, kalau ada EDG attached to the carboxylate ion, it will increase the negative charge on the molecule. Okay, so how? The electron density of the OH bond here akan increase. Why? Because electron donating group, dia akan donate the electron density towards this direction. Okay, this will make OH bond here become stronger. And kamu nak break pun susah. Okay, bila you tak prefer untuk form this carboxylate ion, okay, it is not stable ataupun less stable. So that means H plus ion pun kurang. That is why, okay, bila H plus ion hardly to be released, acidity of the compound pun berkurang. So you can see that bila you have EDG, electron donating group, acidity will also decrease. Okay, compared to tadi EWG terbalik. And strength ataupun size of the EDG also mempengaruhi acidity of the compound. Okay, so kita akan tengok this example. Okay, so effect of electron donating group. Okay, so kita ada methanoic acid dekat sini. Sini cuma hydrogen. So this ethanoic acid, sini CH3. And kalau propanoic acid, you have CH2, CH3. So perbezaannya dekat sini. Okay, so the presence of electron donating group, okay, akan increase the density of the negative charge dekat OH bond. Okay, tapi apa yang beza? Size of the EDG dekat sini. H, CH3, CH2, CH3. So the larger the size of the electron donating group, the higher the electron density of OH bond. Maksudnya dia akan donate more electron density towards this carbon OH bond. Sorry, bukan carbon OH. Carbon OH. Okay, dia akan donate more electron density towards this OH bond. Okay, that is why H plus akan jadi difficult to, susah untuk release. Okay, bila susah untuk release, that means H plus ion kurang. That is why propanoic acid is the least acidic compared to ethanoic acid and methanoic acid. Okay. Okay, so now kita compare carboxylic acid, phenol dengan alkohol. Okay, so kenapa kita cakap yang paling most acidic adalah carboxylic acid followed by phenol and alcohol? Why? Okay, so kalau kamu tengok dekat sini, carboxylic acid dia boleh form carboxylate ion. Okay, so ini H plus boleh, H3O plus pun boleh lah. Dia actually jadi H plus ion. And then this H plus dia combine dengan H2O jadi H3O plus. Okay, so which okay, so kalau kamu tulis H2O, sini produk mesti H3O plus. So kalau kat sini tak ada H2O, terus H plus begini. Right, so phenol pula dia akan form phenoxide ion. So both ini dia ada resonance effect. Okay, tapi apa yang membezakan these two? So one carboxylic ion, resonance effect dia delocalization between two oxygen atom. So remember, oxygen is the most electronegative. So bila dia most electronegative, walaupun hanya 2 saja oxygen atom, dia lagi prefer untuk jadi negatively charged. So dia lebih kuat compared to phenoxide ion. Dia lebih stable lah compared to phenoxide ion. So phenoxide ion ni resonance effect, but the delocalization of electron tu between dalam, so the delocalization of phenoxide ion dalam benzene ring. So between carbon, oksigen dengan carbon, oksigen lebih electronegative. Right, so next alcohol, dia akan just form alkoxide ion, no resonance effect. Alright, so the explanation will be carboxylic acid is the most acidic due to the resonance stabilization of the carboxylate ion. Okay, and the electron in carboxylate ion, they are delocalized between two oxygen atoms. So ini yang membuatkan dia lebih more acidic. Okay, it will increase the stability of the carboxylate ion, and the C double bond O group in the carboxylic acid is an electron withdrawing group which reduce the electron density of OH. Therefore, OH bond tu akan jadi weaker. So bila OH bond tu weak, H plus ion will be easily removed. Okay, so H plus ion will be easily released ataupun donated, and therefore the carboxylic acid, it is more acidic compared to phenol. Okay, so phenol ni pula, it is more acidic compared to alcohol biasa because phenoxide ion yang form. Okay, so phenoxide ion dia ada resonance effect. And the differences here, kalau kamu tengok, the delocalization of negative charge untuk phenol, it is into the benzene ring. Kalau yang tadi, between two oxygen atom. Okay, so phenol is less acidic than carboxylic acid because of the delocalization tu lah. Kalau delocalization of the negative charge between carbon atom, it is less stable, okay, compared to carboxylic acid tadi. So, alcohol yang the least acidic. Why? Okay, because the presence of the alkyl group ataupun electron donating group on the ethoxide ion, it will increase the density of the negative charge on the oxygen atom. Okay, so OH bond to become stronger. Kalau ada EDG, OH bond become stronger. So maksudnya susahlah kamu nak breakkan the OH bond. So H plus ion pun tak banyak berkurang. So it will make alcohol less acidic. Okay, so aliphatic alcohol also unable to make any resonance structure macam phenol dengan carboxylic acid. This will make the ethoxide ion less stable compared to phenoxide ion dengan carboxylate ion. Okay, that is why alcohol is the least acidic compared to the other two. Alright, so now let's have a look at the example. Okay, so ini pun soalan 2019-20. Arrange the compound below in increasing order of acidity. Okay, so basically sama je macam yang tadi kita bincang, cuma ini dia bagi jelas example of propanoic acid, 2-chloropropanoic acid and phenol. Okay, so draw out the structure first kalau kamu tak nampak, and then barulah rearrange them. Okay, cumanya dekat sini you have propanoic acid both, tapi this one dia ada chloro. Okay, so ini. Okay, so these are the structure. Ini 2-chloropropanoic acid, and this one is propanoic acid, 1, 2, 3 carbon, and this is phenol. Okay, so kalau kita compare these three, ini carboxylic acid. So carboxylic acid is the most acidic. Okay, because of the yang tadi kita cakap lah, because of the delocalization between the two oxygen atom, it will increase the stability of the carboxylic ion. Okay, so now phenol is the least acidic. Why? Because kalau kita compare dengan carboxylic acid, of course lah, phenol is the least acidic. Sebab dia hanya delocalization of the negative charge ataupun electron into the benzene ring between carbon sahaja, carbon atom. Okay, so propanoic acid pula, it is more acidic compared to phenol because the negative charge dalam carboxylic ion, okay, it is delocalized between two oxygen atom. And then you have 2-chloropropanoic acid, and 2-chloropropanoic acid, it is more acidic than propanoic acid. Why? Because of the presence of electron withdrawing group ataupun Cl ni. Okay, so Cl dia akan tarik the electron density, so make this OH bond weak and easier to be break. So you akan form a more stable carboxylic ion, and H+ ion pun banyak dihasilkan. Okay, it will stabilize the carboxylic ion. So ini sahaja 4 markah. 1, 2, 3, 4 markah. Okay, so that's all untuk physical properties of carboxylic acid.